Hey, what's up, y'all? Welcome back to another processing tutorial, this one again on images. We're going to continue looking at how we can access and manipulate the pixels of images using the pixels array to this time create a fun, kind of wavy, maybe like funhouse mirror effect that you might see at a carnival or something. But yeah, we're going to look at how we can animate this from a still image, right? This is not, these shapes are not being animated this way. This is just a picture, right? This is the source image here. And I am just moving the pixels around to get this effect. Okay, so let's get started and take a look at how we're going to do this using code. We'll make a new sketch. We'll say void setup, void draw. We need all of our usual size and background functions. Let's say 0 is fine. And then, of course, we will have to save this so that we can add a file to our sketch folder. So I'll just call this wavy image. And then what I can do is I can add a file to this sketch folder. So we'll grab spots. That is now in the sketch folder. Let's say p image image, and let's load it up. So we'll say image equals load image spots.png. Okay, and then let's resize that, image.resize, so that it is the width and height of our sketch. And then let's just draw it so we can see that everything is working. I need, of course, to tell this where to go. Okay, and now I've got just my picture that I'm loading in displayed here on the screen. So we're going to take the same approach that we did last time, where we sort of create an empty image and then we copy the pixels over as we need them and display that copy of our image. So let's go here and say wavy image, right? And we'll say wavy image equals create image, also width, height, and we just need RGB color mode. Okay, right. And so now we're going to do the same thing that we were doing before. We will say a couple of nested for loops here for int x equals 0, x is less than width, x plus plus. Need the right punctuation there. And then we'll say for int y equals 0, y is less than height, y plus plus. Okay, and then inside of here, if we just wanted to create a one-to-one copy of the image, we can of course say int location equals x plus y times width. That's that same equation from the last video. And then we would say, you know, for every, let's go ahead and image.load pixels. And actually I can just, since I'm not really going to ever update these pixels, I can load that here in setup and those will just stay in memory. And then I will say wavy image.load pixels. And then down here I will say wavy image.update pixels. And then instead of drawing the image, I'm going to draw the wavy image, right? And then here I can just say wavy image dot pixels at this location that we've just determined is equal to the pixel in the image pixels array, right, at that same location. Cool, so now we've got just a copy of this image here for us to see. If we want to actually determine the offset, right, so if we want to actually start to move these pixels around to get that wavy effect, what we need to do is offset the x position of some of these rows of pixels, right? And so let's say, for now, how about loc2, right, equals x, right, plus x offset plus y times width, right? And we don't actually have x offset, so let's say int x offset, right? And let's come in here and let's say x offset equals mouse x, like this. Okay, and then at this location, I want to put the pixel, right? I'm going to take the original pixel and I'm going to move it somewhere else. And actually, I also want to make sure that I never go somewhere that is outside of this array, right? Because if I try to go somewhere, so if this gives me a value that's larger than this index actually is, right, then I'm going to get an error, right? So I probably also need to say constrain all of this stuff between 0 and width times height, right? So all of this stuff, the second location, I don't want it to ever be less than 0 or greater than width times the height, which is just going to give me the number of pixels in this array. We'll see what this does for us. I think, oh yeah, out of bounds. Right, okay, because it's starting from a 0 index, so I need to actually say -1 here. Let's try that again. Okay, and so now you can see as I move my mouse across the screen, I am offsetting the x position of each of those pixels. Or I'm copying the original pixel to a different location, right? And so what I can do if I want to get that wavy effect, right, is instead of having each x offset be exactly the same, what I need to do is I need to actually also kind of relate this offset to the y position. So I'm going to multiply the amount of x offset here by the sine of an angle, and that angle is going to be also mapped. Okay, so let's take one thing at a time here. Let's first mess around with this offset, right? And here's what we're going to do. We're going to say int x2 equals all of this stuff. And then we'll say x2, right? So we want to mess around with this offset based on a sine wave. And so I can say times sine of angle. Okay, and so of course angle does not exist, so let's make an angle variable. And we are going to make this into an integer, right? So this is now our offset times a sine wave, right? And this is going to go between 0 and 1. And we need to increment the angle every time. Let's see what that gets us. Okay, so as I move my mouse over, you can see now my sine function is just spitting out values between 0 and 1, or sorry, -1 and 1, right? And so it's multiplying this offset amount by whatever that happens to be at that moment. So that sine function over here is going between -1 and 1. And if I increase my x offset, right, so now my x offset should be like 320. It's going to go between 320 and -320. Right, excellent. Okay, so that's how we're, affecting the x offset, right, using this sine function. Now, I actually want to also map my angle. So let's see, so that I can get some kind of difference in the y dimension as well, right? So if I mess with this angle and I say, let's add y mapped between 0 and height, right? I want this to be between 0 and 2 times pi. So I can say 2 pi here, right? So what this is going to do is it's going to, when y is equal to 0, right, it's going to add the angle, which is, at the very first frame, it's 0, right? So it'll be 0, but at the height, it will be 2 pi, right? So then even though angle itself is 0, when y is equal to height, right, because this is inside of this for loop where y is changing, each of these columns, right, it's going to be all the way over here, right? Or it's going to be, basically 2 pi. So we'll have made a full rotation. So it'll be, -1 all the way to 1 back to -1 there, right? So let's run this and see what we get. Right. Okay. So it starts at 0, right? Goes to -1 to -1 back to 0. And so you can see by mapping that y amount and adding it to the angle, right, we can get another, we're offsetting the angle now of the sine function based on the y position. And that's pretty much it. There we go. Okay, so I think in the example code, I had a couple other controls. I said no cursor, just so we could see that a little better. And then I think I also said something like speed and did this. And I can then, what I can do is I can say speed equals map mouse y between 0 and height between -0.01 and yeah, let's do 0.05 and 0.05 here. So this will allow me to kind of speed up and slow down the animation, as well as increase and decrease the actual x offset. So I can go faster, I can go slower, and I can also go the other way. It's kind of fun. Let's give you a few more controls over this little visual here. Okay, so now you've seen another way that you can play around with accessing all the pixels in images using the pixels array, and do a few more things here where you're offsetting position of the pixel that you're copying into to get some very fun effects. So play around with this, experiment, kind of, maybe play around with getting different kind of image glitch effects out of this technique. And then join me in the next video where we look at how to use images and P graphics together to create a kaleidoscope effect.